Let's solve this 2013 Integration Level 3 question. Ben leaves his cup of coffee on the table to cool. The room's temperature remains constant at 18 degrees Celsius. The rate at which the temperature of the coffee changes at any instant is proportional to the difference between the temperature of the coffee and the room temperature at that instant. So first, let's write the differential equation that expresses this statement. Now, that should be d big T over d small t, which is time. The temperature over the time is equal to some constant k multiplied by the temperature of the coffee minus the temperature of the room, which is 18 degrees. Now, the next step, the temperature of the coffee when it is poured is 65 degrees Celsius. After 2 minutes, the temperature is 62 degrees Celsius. Solve the differential equation in I to find how long from when it was poured that Ben has to wait before he can drink. So first thing we need to do is we need to integrate this equation. However, it's a little difficult, so let's get t on the same side as dt and k on the same side as d small t. That should be 1 over t minus 18 d big T is equal to k multiplied by small t. And then if we integrate that, we'll get the ln of t minus 18 is equal to kt plus c. And then we can just take the e function of both sides, so we'll get e and ln cancel out. T minus 18 is equal to e kt plus c, which we can rewrite because the exponents are the same as e kt e c, which is the same thing as this. And now we get that t is equal to e kt e c plus 18. Temperature of the coffee when it's poured is 65 degrees Celsius. So that means that, this is very confusing, but at t equals 0, t equals 65. So 65 is equal to, this is just 1, so it's just EC plus 18, and that means that EC is equal to 65 minus 18, which should be equal to 47. So that means that t is equal to EKT times 47 plus 18. And then that means Ben, after 2 minutes, the temperature is 62 degrees Celsius. So at t equals 2, big T is 62. E2K is equal to 62 minus 18 over 47, and if we take the ln on both sides to cancel the e, we'll get that k is equal to ln of 62 minus 18 over 47 over 2. Now I can't calculate that in my head, so I'll just plug in the calculator. And then if we plug this all into the formula, we want to figure out when Ben can drink the coffee when the temperature is 54 degrees Celsius. So when does big T equal 54? And then just doing some rearranging, we get that 8.085 minutes.